Alright, so this is going to be what I hope to be a fairly quick tutorial on how to set up the Lumen pick-and-place machine in OpenPnP from start to finish. When I say start to finish, I'm not going to get to things like feeders or parts or packages. That's all going to be pretty specific to your own setup, depending on where you're going to be getting those from, depending on what feeders you set up, what software you're using for your boards and stuff. And there's already a lot of tutorials out there for that specific stuff. But what I'm wanting to do here is go from a completely blank configuration to having the base machine itself set up, having all the machine definitions, having our vision pipeline at least started for fiducials, having our nozzles set up, and stuff like that. So I have a machine with both heads populated, but most of this setup is going to be relevant to single-headed builds as well. So without further ado, let's just go ahead and jump right into it. So first of all, when you're setting up a new machine, this Issues and Solutions tab is really going to be, this is going to be where a lot of it's going to happen. It's either going to be here or it's going to be over in the machine setup. So to start with, this machine, whether you have a single nozzle or not, you want to select this nozzle pair shared z-axis negated. This is something that I don't think the official Opulo configuration file in the GitHub repository used. Part of the reason for this, well, the main reason for this is you've got your two heads, and if you set it up as a single axis, it's going to take it so that all the way down is 0 and all the way up is about 62 on this. But at that point, let's say that this left nozzle, when it comes all the way down, it's at like a Z of 10. If the right-hand nozzle comes all the way down, this nozzle is going to be up here, and that's going to be around 50. So when you say that your board is at height 20, well, that's only height 20 on the left head. You want that same Z height to show up on the right-hand head. And that's how this is set up to work. Now, the official documentation seems to imply that the intended setup for this is going to be where the two heads are, when they're lined up evenly like this, that is our 0 point. And then anything below that is a negative. And so that's how I'm going to set it up here. You could set it up with a full range where all the way to the bottom is 0 and all the way to the top is 61, and then map this opposite. But I'm not going to do it that way. I'm going to set it up so that 0 is in the middle. So with that out of the way, we're just going to go ahead and accept. This is going to give you a warning. We have a brand new machine, so yes, of course, it's going to change the configuration a lot. So that is going to complete this first milestone. Pretty simple. So now we come into here, and again, we're just mostly going to accept these first couple things. It's going to replace the simulation cameras with real cameras. So we're going to do that, and then we're going to replace the G-code driver with the null driver with the G-code driver. So now at this point, we're going to come into here, and our two cameras, one of the cameras is going to be attached to the head, and the other one is going to be attached to the machine. This is our bottom. So you come in here, we're going to go to Device Settings, and under this drop-down menu, if you have an official Opulo kit, these two cameras should have unique names. One of them should be named top, the other one should be named bottom, and that makes it a lot easier to figure out which is which. For me, I just already know that this one should be the top camera, and it looks like it is. And this one should be the bottom camera. And it looks like, yes, it is. Bottom camera is looking straight up into a fluorescent light right now, so it's completely blown out. But that's all right. We'll get to that later. Now we're going to go, let's see, down to drivers and our G-code driver. I'm going to go ahead and rename this to Lumen PnP controller. You don't have to rename this, I just like to. We're going to go communication type is serial. Your port number is going to depend on your computer. On mine, it's COM4. And then later it will complain if you don't set your flow control. So we're just going to go ahead and do that now. RTS, CTS. Now we're going to come over to driver settings. We're going to want to change our command timeout to 30,000. Otherwise, you will get complaints about it timing out when you do things like homing or when you go to do backlash calibration. So we want to make sure that that is set there. And then we're going to detect our firmware. Now, the board is powered on right now. It won't be able to detect firmware if it's not powered on. But we don't actually have to have it connected. We just have to have power physically attached. Okay, so it found that. I'm going to say OK. Now we're going to go back to our issues and solutions. We're going to click this again to refresh this list, and that's going to be everything. So we're going to accept, and that is milestone connect. Now we're going to be doing a bunch of stuff with defining the axes on our machine. So let's go ahead and collapse all of this, and we're going to open up axes. First thing here, I like capital letters for my axis name, so I'm just going to rename that. And our axis letter is X. Let me see here. I actually have my settings written down. Let me just pull that up. Here we go. So these settings, I'm just going to kind of quickly run through them. These are the ones that I've found to work on my machine. If you want to dial in your own, I would suggest starting lower than these values and then working your way up to figure out kind of where your limits are. So here we're going to enable our soft, low, and high limits. Low is going to be 0. Top, or our high for our x-axis is 430. Speed rate of 200. An acceleration of 500. A jerk of 0. For our y, again, capital letter, give it the axis letter y. Enable our low and high soft limits. Again, this is 0, and here this is going to be 480. Now for my y-axis, I like to go a little bit slower. I'm going to go a speed rate of 150 and an acceleration of 300. This is still pretty conservative, so I might be able to go a little bit faster as we go, but that's where I'm at right now. So let's see here. I'm actually going to delete this z-top. And the reason for that, the official documentation suggests that you assign a virtual z-axis to your camera. And as far as I can tell, I believe the only really useful reason for that is if you have a camera that has software-controlled focus, so that you can map your focus to specific z heights. And then if you have different things at different heights, you can then have it autofocus at those different heights. We don't have that, and so it actually causes some weird issues, especially if you use these buttons here, the move camera to tool position and move tool to camera position. If you have a virtual z-axis, sometimes it will move the virtual camera up and down. It'll think that it's moving the camera up and down, and then you go to move the nozzle, or you move the tool to that point, and it moves it in the X, Y, and Z dimensions, and you can have it just plunge into the bed for seemingly no reason. It causes all kinds of problems. So we don't have a variable focus camera, so we're just going to go ahead and delete this. Okay, so our virtual rotation, on the other hand, this doesn't have those drawbacks, and I think it's used to draw the crosshairs here and allow the crosshairs to be rotated. So I find that to be somewhat useful, so I will go ahead and leave this. I will, however, move it all the way down. So the way that they do this z-axis thing is not actually quite how I would want to do it. So what we're going to do here is there's z1, we're going to call that z. And now we are going to add actually real quick. So z-axis, we're going to enable all 4 of these safes, the safe values. here I'm going to set this to my absolute Z midpoint. For me, that's 31. For some people, it's like 31.5. You'll want to figure that out for yourself, and you will use that value here in a couple of different places when we get to the mapping. So keep that in mind. For me, it's 31. We're going to go ahead and put that in. Feed rate of 200 and acceleration of 200. Okay, so we renamed this to Z. Now we're going to add a new mapped axis, except that we're going to move it up, and this is going to be Z1. Although I'm going to call them ZL and ZR. So right here, again, because my midpoint was 31, you would put 31 here. If yours was 31.5, you'd put 31.5 here, and then you would put 32.5 here. You want these to be, a difference of 1 because they're mapping to a difference of 1. Let's see here. So for the left one, it's 31 and 32 are 0 and 1. And over here for ZR, again, this is your midpoint, and then this is your midpoint minus 1. So 30 is 1. So that's our z-axes. Now our rotation axes, because Marlin calls them A and B, I'm going to go ahead and call them A and B. Let's see, so A, we're going to disable this limit to range. This will come back in later, but we'll let it automatically handle that. So I'm going to uncheck that for now. I'm going to do 150, 100, and a jerk of 0. Now here's our second, here's B, unchecked, 150, 100, and 0 on the jerk. Okay. So now that we have done that, let's check our camera, our top camera. Sorry, not bottom camera. We're going to check our top camera under position. So this is that Z axis that we deleted, and we want to make sure that this is set to nothing. You got X, Y, and C. That is correct. And now we also want to go into our nozzles, not our nozzle tips. We go into our nozzles, and nozzle 1. We want to make sure Z is assigned to ZL, not to Z. And then for N2, it should be ZR. Rotation is B. So those are both correct. Let's see what's next on the list. Next on the list, okay, we want to go into our nozzle vacuum actuators, and I want to set these to nothing for right now. Because now that we have set that up, well, first let's come back here. Great. Axis letter is missing for Z. Oh, when I created that Z axis, I did not put the Z here. Okay. So that is why this this window is so helpful, because when you make a stupid mistake like that, this will, this will catch that. So nozzle is missing a vacuum actuator. Yes, it is. So let's do our actuators next. So we've done our axes, now we'll do our actuators. First of all, I want to delete the ones that they've automatically created, because some of the auto-generated stuff gets set up slightly different than a default one when you just create a new one, and I like to just start with the new ones. So I'm going to create a bunch of new actuators. Now for the vacuum pump and the solenoid, I prefer to actually name these based on what they are labeled as on the controller board rather than their function. So for these, it's going to be MOS 1 through MOS 4. And then, real quick, actually, I'm just going to create them all, and then I will come back and actually set them up. So MOS 1, MOS 2, MOS 3, MOS 4, and then after that, we are going to set up our vacuum actuators. These are our vacuum sensor actuators, I should say. Those are our sensors. And then one last one is top lights. And finally, we come down to the machine, not the head. So these are all considered part of the head. We're going to come down and create one for the body, and that's going to be the bottom lights. Okay. So now we're actually going to configure them. So for these, we're going to want to make sure our value type is Boolean. Machine state enabled is going to be actuate off. Homed is going to be leave as is, and disabled is also going to be off. Finally, we're going to want to make sure to set our indexes, because we're going to use the index variable in the G code later so that we don't have to hard code the index into the G code. It makes it a little bit easier to just copy and paste all of the G code commands. So for the MOSFETs, they start at index 0. So MOS 2 going to be, again, Boolean, actuate off, leave as is, actuate off, and index 1. MOS 3, again, Boolean. Here, this is going to be index 2. MOS 4, Boolean, actuate off, index 3. Now the vac sensors are going to be a value type double. We're going to say assume, we're going to leave these, assume unknown, and then leave as is. The vacuum sensors start with index 1, so their index is 1 and 2. Again, we're going to go double, assume unknown, index 2. And now our top lights, these are Boolean. Eventually, I'd like to figure out how to set up a profile so we could do like multicolor, or we could do, you know, high, low, medium, set different brightness, whatever. But for now, we're just going to set up Boolean because I don't know how to do the profiles. So the top lights are actually index 1. The bottom lights are index 0. So I want to actuate them off. Bottom lights, I'm going to actuate off, and you are index 0. There we go. So that is all of our actuators created. Now we're going to assign some of those actuators. First of all, go up to your reference head and scroll down to vacuum pump actuator. Right now, this is going to be MOS 1 because I only have one vacuum pump, even though I have 2 heads. So that probably isn't going to work properly, but I haven't tried it yet. If you do have 2 heads like mine and you have 2 pumps, the correct way to do this would be to create another actuator that is a profile actuator that you would call it like pumps or something. And you would have that profile actuator control both MOS 1 and MOS 3. And then you would come down here and you would set that as your vacuum pump actuator. Right now, I only have MOS 1. I only have the one pump. I'm going to do this. But if you wanted to control both pumps on and off with this actuator, that's how you do it. Create a reference actuator, a profile actuator, have it control MOS 1 and 3, and then set the profile actuator here. Okay, so that is the head actuator, now we're going to go to our cameras and we're going to set the light actuator. That's under the general configuration. Top lights. Now let's see here. Yeah. I'm going to set anti-glare. You'll see now this light symbol popped up, which means, actually, never mind. We can't do that yet because we don't have our G-code set. I was going to say you should be able to click there. Also, the machine's not started, but you'll be able to click here to turn the lights on and off. Now we do the same for the bottom lights. All right, bottom camera. Light actuator, bottom lights. Turn on anti-glare. And apply, and there we go. Now we're going to go to our nozzles and those vacuum actuators that we deleted before. Now we're going to come in here and we're going to say vacuum actuators MOS2, sensing actuators VAC1, apply. Here it's going to be MOS4 and VAC2. So now those are assigned. I think that's all of our actuators for now until we get to the G-code. Okay, the vacuum valve actuator has no Boolean command assigned. Yes. So now we're going to do, so yeah, let's do our G-code now. So I'm going to scroll down here and find driver does not report axes in the expected YCAB. Yes. Yeah. Okay. Don't worry about that. I'm going to go through here and I'm going to accept these suggested G-code related issues. And this is going to set up a bunch of our default G-code in the G-code driver. And I found that these seem to work. So just go ahead and use those. And then we are going to go add some more commands manually. So you come to your drivers, your G-code driver, and you come to G-code. So let's see here. The first one that I'm going to do is I'm going to do, got my top light. And then we're going to go actuate Boolean command. And here is the command that I'm going to use. And I'm going to leave it up here for a second so you can see it. Basically, the way that this works, this index is referring to the index values that we set up for our actuators. So that's why I wanted to make sure that we set those, because it makes it easier to copy and paste stuff and then just reference the index here. Now, the one thing you may want to change here is this this value right here. This is going to be the P value, which is the brightness for your ring light. And that's something you're going to have to dial in on a case-by-case basis, along with your brightness and contrast and gain and gamma settings for the camera itself. So I found 30 works for me for my top-down. That's something you may have to come back and change later. So that is our top. So next up is bottom lights. Also actuate Boolean command. So for my bottom lights, 50 was what worked for me. So I'm going to do that. Next, let's go ahead and do our MOSFETs. Let's see, let me copy that. For these, it's also actuate Boolean command. And here is the code that I used for this. Basically, what this is saying is that to actuate for true, you will get M106 S255, and for false, you get M107. And then P is the index of the MOSFET. So this one will actually be the same exact command for all 4 MOSFETs because we're using the index. Next up is our vacuum sensors, and for our vacuum sensors, we actually have 2 commands that we have to configure. The first one is our actuator read command. And one thing you will have to configure here is the A flag. This actually depends on the chip that you have on your board for your I2C digital to analog converter. Basically, if you take this G-code command and you paste it into the console here, if you get back an I2C read error, come in here and try a different address. I think addresses from 0 to 7 are potentially valid. For me, the chip that I have is an A2. If you have a kit motherboard directly from Opulo, those should all be A0, I believe. But so if you get an I2C error, that's what you need, is you need to change your address. And also you need an updated firmware on your board in order to support this. I believe the older version of the firmware did not support the A flag. Once you figure out what your address is, go ahead and hard code that because it'll be the same for both vacuum sensors. And then you have your index there. So there, back to actuator read command. And then we need a regex, a read regex, in order for it to decode the response that it gets back. Do that for both. Okay, so that's our MOSFETs, that's our vacuum sensors, that's our lights. So that should be all of our G-code. We'll refresh this. So now axis A should be treated as linear. We're going to accept that, yes. Be treated as linear, yes. Does not port axes in the expected pattern. I believe this actually does report the axes in that pattern, but let's go ahead and check that really quick. So first up, we're going to go ahead and power on the machine because we can actually do that now. And it should work. And now I'm going to go in here. I'm going to check under the default the position report command, I think. Get position command. Here we go. I'm going to send an M114 in the console and see what we get back. So we do. We get back X, Y, Z, A, B, and C, which is exactly what we wanted. So this error is not actually accurate. Oh, there we go. So it went away because once we connected and it actually received back a command, it realized that it was in fact fine. It doesn't. I think the problem there, I think, is that it doesn't recognize this this like custom Marlin firmware name string. I'm not sure. It might also just be that Marlin isn't really heavily standard. Marlin isn't one of the main firmwares that are intended for use with OpenPnP. I believe that that OpenPnP is more geared towards smoothieware, so it might just be that there's some weirdness there. But that tells us that we are done with milestone basics. So here we have, it's asking us for a dynamic safe Z for N1 and N2. This is a smart thing to do. What it does is when you tell it, here's the safe height that it has to be, if there's actually a part on the head, it will it'll raise it up a little bit further. I am going to go ahead and just go with fixed safe Z for now. It's something you can go back and change later. But for now, I'm going to, wait a minute. No, that's not what I wanted. Yeah, okay, sorry. I was a little confused there. Yeah, so I want to set both of these to fixed safe Z. And then we're going to dismiss setting the safe Z because I want the safe Z to be 0. Because remember, our 0 point is when the heads are both in the middle. So that's as safe as you can get, is to have both heads as high as they can get without the other head plunging down. So now we're going to set the feed rate. Okay. We already did this, but because the value I chose was the same as the default, it thinks that I didn't do this. So we're just going to dismiss that one. Rotation can be optimized. Yes, we're going to do that for both heads. I'm going to say yes. Choose an advanced motion control type. Yes, we're gonna go ahead and do that. Axis velocity limited by driver maximum feed rate. So because we've already set our maximum feed rate for all of our axes individually, we can remove the driver minimum, or the driver maximum, and that is going to be milestone kinematics. Now that, now that kinematics are set, we should be able to home. Now, it's probably going to, well, it's almost certainly going to fail when it tries to do visual homing, but because this is a brand new machine, it actually shouldn't attempt visual homing, I don't think. Okay, good. There we go. So now we have our 0 position set. Now let's go ahead and jog our head over, wait, no, okay, I'm reading my notes. Before we do this, we actually need to, do the millimeters, units per millimeter. Give me 1 second, I need to go grab my ruler. Okay, here we go, got the ruler. So, OpenPnP has this ability here, under the axes. It has this setting right here for steps per millimeter. However, this setting doesn't seem to actually work with Marlin. The steps per millimeter is kind of baked into the firmware, and it doesn't seem to be something that can be changed here. But it is still something that needs to be dialed in, as I found when I realized my machine was set to 40 steps per millimeter, or whatever unit Marlin stores it as. It was set at 40, and I'll go ahead and show you really quick what happened. So M92, I believe. Yeah, there we go. So M92, I have it set to 39.885 because that's what I ended up getting. But let me set it back to 40 just so you can see what I was getting when I had it set that way. So now let's move. Let's see. So this is really bright. I think before we do this, let's get our cameras dialed in. Sorry to be jumping around like this, but I need to get the cameras dialed in before we can do this. So let's go top camera. First things first, I need to flip vertically and horizontally because I can tell that the camera was flipped. It was definitely flipped vertically. Let me just check. This should be coming in from the left. Yeah. Pen's coming in from the left. So I do want that flipped horizontally. And I believe that I need bottom camera is going to be really hard to see right now because it's so washed out. So let's come in here. I would highly suggest unchecking auto for all of these because you want to get these settings dialed in, and then everything is going to be based on these settings in your vision. Things like your thresholds, things like your contrast and your blur settings and things like that. And if these settings here decide to start automatically changing, you're going to be in for a bad time. So start here. I like to start with things mostly kind of centered. Let's see here. Exposure, like a -5 looks good. Oh, my saturation is gone. There. Okay. So the other thing is when you're setting this up, turn on your ring light. Okay. You need to make sure that your ring light is turned on because that is going to inform your decisions, like your contrast and your gain and your gamma. Let's set this to camera top. Okay. So for here, it's important for fiducial location that we can clearly see the middle dot separately from the outer ring. If we were to set this up higher, you could see that all of a sudden this is completely washed out and you can't see it anymore. So we might even bring it down to like a -7 and then bring it back up with gain and gamma. Ooh, that's a lot of gamma. No, see, that's not very good. So actually, I'm going to bring the contrast. Sorry, not contrast. I'm going to bring our exposure up one step. Yeah, adjusting brightness doesn't help either. So yeah, let's bring our exposure up one step. Now it's really blown out, but we can bring that back down with the gain all the way down and our gamma all the way down. Now you can kind of see here where the ring light is actually really visible, and this is a situation where you might then want to go in into your G code and turn your brightness down on your ring lights. So let's see what would happen if we went with 10. So that's not bad, but there's not much to it. Let's try 20. You want even lighting is what we're going for. You don't want this halo here. You want to reduce it as much as possible. Let's try 15. So this value right here is out of 255. So I've got my lights turned way down. But you can see that that actually does give you pretty decent visibility. And another good idea is that when you're figuring this out, not only do you want to be looking at your fiducial on your datum board, but go ahead and put an actual like production board on here and take a look at that and see how this looks. And you can see there's bright spots around here, and then it's a little bit dimmer in the middle, but still there's a good contrast, and I think that that would still be a pretty decent, that's probably enough light, I think. Okay, bring this back down here, and then we'll go back to our camera settings. If I bring the exposure up, that's not too bad. Let's see what it looks like on the regular board with the exposure up. Actually, you know, I kind of like that. So we're going to bring our exposure up, gain down, hue. Okay, so power line frequency here. This one's important because it's for reducing flickering due to the frequency of your power lines. So what you need to know is 0 turns it off, 1 is for 50 hertz power, like in the UK and I think most of Europe. I'm not actually sure. In the US here, it's 60 hertz, and a 60 hertz is a 2. So that's what you'll want to set it to. Now, I like to turn my saturation all the way off so that I get a black and white image, because this gives me a better preview of what the vision pipeline is actually going to see. So I can see if there's any issues when the vision pipeline is going to be turning things into black and white. So this will tell me whether or not there's a nice clear brightness contrast here. And there is. So my white balance for me is about 4600. Go ahead and set that. Cool. So I think that is going to be good for that camera. Now let's go to the bottom camera. You can see this is very, very washed out. I'm guessing the exposure, let's see here, turn off all the autos. Yep. Okay, yeah. So exposure is set way too high. Oh, wait. Okay, 5. I still have top camera selected. Bottom camera. Yep, there we go. Center it out. Power line frequency 2, sharpness 3, white balance 4600. Okay, so now, again, remember, actually, I'm going to turn off the top because that will cause glare. Make sure to turn on the bottom lights. And now let's go ahead and, oh, okay. So here, you want to flip vertically. There we go. Okay. Device settings. So let's see. Okay, that's really bright, especially with the backlight. So I'm going to stick with that. I think maybe my bottom lights might need to be a little bit brighter. Or maybe not. I don't know. Let's see what this looks like at, say, 100. That looks pretty good. So another thing to be paying attention for on your bottom camera is you want to see how clearly these rings show up, because that'll be really helpful in getting your nozzle centered in the camera later. So let's see if we up the contrast a bit. Does that help? Sure. I up the gain a little bit. Yeah, maybe 30. And then saturation down again, white balance. Okay, so I'm gonna go with that for now. We can come back and adjust this later. But what I wanted to do, something to do often, save your configuration often. Don't want to lose that. Let's go back to our top camera. Let's turn off that and we'll go back to our top camera. And now we're going to set up our steps per millimeter. There. Now this ruler is nice and clear. Okay. So what you're going to see here, I'm going to try and get this centered on the line. So we're a little bit on the right-hand side of center, but we're solidly on this line. Now I'm going to move it 200 millimeters. And you can see we've actually advanced about 0.5 millimeter. So that tells us that if we go into here and we do the M92, so our X is at 40, and what we would want to do is 200 divided by 200.5 times 40. Let me see what that would be. So 200 divided by 200.5 times 40 gives me 39.9, which is really close to what I came up with previously. I had 39.885, and I'm going to go ahead and stick with that. But that's how you would calculate it. You take the distance you traveled, or the distance you told it to travel, which is 200, divided by the distance you actually traveled, 200.5, and then multiply that by the step value here. And then once you know you've got it right, let's go back to here, and here now we're almost dead center. We're going to send M92 X 39.885, and I happen to know that my Y is also the same, and I'm also assuming that my Z is probably the same because it's the same motors and the same gears and the same belts. So we're going to do X 39.885, Z 39.885. We're going to send that, and now if I send an M92, I'm going to get back 39.88, 39.88, 39.88. Perfect. So now if I move 200, dead on. And back to dead on. So because the OpenPnP setting up here in axes doesn't work, what I've found works as a workaround. You take this M92 command and you come into the G code for default connect command. And then you're going to go here, set steps per millimeter, and apply. The other thing that you can do here, you can also do an M906 to change the stepper motor current, how many milliamps gets sent. You can set that here if especially the Z rotation stepper motors have been running kind of hot for some people using the default. So to figure that out, you would come in here and you'd run an M906, and it gives you your X, Y, Z, I, J, K. So I is your A or your left motor, and J is your B or your right motor. So you could send an M906 I 200. And then if we send M906 again, we'd see that, it didn't change. This is something I've got to figure out. It seems like it doesn't accept I, J, and K as the parameters there. I'll have to look into that. But if you do figure out what currents you want to change, you can put an M906 command in here to do it, in theory. So that gets us our steps per millimeter. So now, actually, because we have changed our steps per millimeter, we're going to want to rehome, because that's actually going to affect the positions of everything on the board. if we've changed that from its default. So now we're going to go ahead and find our foaming fiducial. Actually, so we're going to zoom out, and we're going to set, so we've set our steps per millimeter. Now we want to do our visual pixels per millimeter. And to do that, we go into heads, camera, and let's see, where is it? Camera. Under general configuration, we're going to click measure, and here. And you want to line it up with the center of the lines. And now this grid is 5, 10, 15, 20 in the X and 5, 10, 15 in the Y. 20 and 15. And confirm. And now we're going to get 33.16, which is really close to what I had fine-tuned earlier. So I'm going to go ahead and change this to what I came up with earlier, is 3375. 3375. So apply. Now, it's a little bit trickier for the bottom camera because things are going to change in size visually depending on how close or far away they are from the camera. So you're going to want to do this calibration probably with a part stuck on the nozzle. But for now, I'm just going to give it the same size. Even though it's not accurate, it's still a better approximation than this default. But you'll want to, once you have things getting picked up, pick up something that's a known size, like a resistor or a capacitor, bring it over the camera at the focal distance, which should be at this 0. Some people have been setting it up with the camera focused with the nozzle all the way up. That's not a good idea, because if you move this nozzle all the way up, this nozzle is going to be plunged way down all the way through your plate, and you're gonna damage stuff. So don't do that. Set your focal plane with the nozzles at 0. So now that we have set up our pixels per millimeter, oh, you know what? Actually tell that that is slightly off. If I go here, yep, that is slightly off. So I don't know if I'm not sure what changed there, but you can see that these should line up, and this should line up, and they don't quite. So let's try this 3333 that it came up with. Let's see what that does. Better? No, not really. Oh. No wonder I have the bottom one selected again. So top. What happens if we go 3, 5? Right now, too narrow? Does that make it narrower or wider? Okay, that makes it narrower. Let's do 33. little too wide. And now let's do the 33,333. Yeah, that looks really close. That'll be close enough for our needs now. So, what is next? Fiducial calibration. Well, first let's come back here and do this. Okay, so fiducial calibration. You can run the auto adjust. It'll take it a while, and it might find this. It might find this. It might find this. If you already know pretty close to what the size is going to be, like I know that the size is going to be 30, then just go ahead and type in 30 here and then click up and down and watch this score up here and try and find what gives you the best score. So like 5.6 or 5.2, 5.7, so right there, 31, looks like 31 gives me the best score. I like just leaving it at 30 because it's a nice round number and it's still close enough to the high score. So once you get that, then you click accept and it's going to attempt to home on that fiducial. Okay, so that worked. Now we're going to do the same thing for the secondary fiducial. So now this is another thing that I believe is only really relevant if you have a camera with controllable focus, because it wants you to pick a fiducial with a different Z height, and I'm pretty sure that that's so that it can calibrate the autofocus feature. Now we don't have the autofocus feature, but it still wants a secondary fiducial, so we'll give it one. This one, so you can pick any of the 4 fiducials around the edge. I'm just gonna call it this one. Again, I'm gonna give it 30. We're gonna accept. And you should be seeing these green circles that tell you that it locks in. If you're not seeing that, then you've got something wrong, either with your lighting or with your pixels per millimeter or with something else. Maybe your camera isn't clearly in focus or you picked the wrong size. Could be a lot of things, but you want to make sure that you see those preview markers. So we're going to enable the visual homing. Yes, I'm going to ignore the nozzle offsets for now, because I actually think that I have found a better way of finding your nozzle offsets a little bit easier than the way that they suggest in the documentation. So we're going to go through here. We're going to accept their changes to the cameras. Okay, find. So, okay. Okay. So here is, let's see. We're going to go with, actually turn this off, and we're going to go with bottom camera. Here is, oh wait, here's how I like to do my nozzle offset calibration. So you select your bottom camera, and then you want to center it on, oh, come on. Okay, camera bottom. No? Okay. machine setup, under your cameras, turn off this user camera action. Otherwise, anytime you jog it, it'll turn on the top camera, which we don't want. And also turn it off here, because it's just going to cause glare. Turn that off. So now we just want to look at the bottom head and try and get this. Why did you? No. Also, auto camera view. Okay, I think that was one of the things that the issues and solutions just automatically did, is it turned on this auto camera view. I don't want auto camera view. So turn that off, because I am trying to look at the bottom camera. Okay, there we go. Now it's behaving. So, center your bottom camera in the crosshairs like this. As close to centered as you can get it. Now, what we're going to do, let me think about this. You know what? Sorry. We will do this first order approximation for the primary fiducial. This will actually be helpful. So what we want to do is go ahead and turn that off. Go back to the top head. And we're going to jog the head so that the left nozzle is over the primary fiducial. And we're going to select make sure that the head is selected here when you go to do your Z. If you start clicking your Z up and down and the head doesn't go where you want it to, or the head doesn't move at all, you probably have camera selected, like this. You're clicking, you get nothing. Come here and select nozzle. And all of a sudden, your nozzles will work. So, this does not have to be super fine-tuned, okay? Just go ahead and get it close. And then come here. Go ahead and hit park before you capture it, because this is another one of those scenarios where adding a Z offset to things involving the camera just causes weird things to happen. Like, you tell it to move the nozzle to a position and it jams the nozzle straight through your circuit board. So do that. Ignore this for now. Now that we have a good initial estimate, now bring up your bottom camera, center it on the top camera. Oops, keep doing this backwards. And here's the magic of how we are going to fine-tune our nozzle offsets. Come up here, you select nozzle 1, and then you go back to camera. The reason for that is that this button says move the last selected tool to the camera position. And by selecting nozzle 1 and then back to camera, you tell it, I want to move nozzle 1. Otherwise, it might move nozzle 2, depending on whichever one was the last one you did. So after you select that, click this button. And you'll see it's not quite there. So now we're going to go up here, we're going to go to our nozzles, and we're going to go to our configuration, and we're going to just care about our X and Y. So it's up and to the right. So if we want to move it to the left, I believe we want to increase our X, or rather decrease because it's negative. Before you make any changes here, make sure to click this and recenter it back on the camera. So we're back centered on the camera. we are going to go negative 23.5, and we're going to try this again. Nope, not quite. Try negative 24.5. That's actually worse, so I was wrong. So move it left, we increase this. It's a little bit better. Let's try 22.75. Try 22.85. And this doesn't have to be like super nailed in down to 3 decimal places. I usually just do to like 1.5 decimal places basically, because your vision detection will correct beyond that. So you just want to get this pretty close to centered. So now to move this down, again, recenter your camera. Let's try it negative 67. Okay, that did it. So 67.5. You always have to apply here in order for it to actually make a change. You want to apply it while it's centered. There, that looks perfect. So that is our left nozzle offset. And before anybody is wondering, yes, this does not account for runout. So if your nozzle wobbles back and forth as it spins, that's not going to be accounted for here. It will be accounted for when it does the visual homing. So this gets us close enough to be to get dialed in with that. So now we're going to go back here, and now we're going to select nozzle tip 2, and then back to camera. Now, nozzle tip 2 doesn't have anything selected, but we're going to go in here. We're going to do X, but we're going to flip our X to a positive. And then our Y, we're just going to copy that over. We're going to use that as our starting point. Same thing. Tap this, and now the right nozzle should be over. And it's, not quite, but it's close. So to bring it to the left, I believe I want to make this bigger, right? Or did I get that wrong again? Not sure. 25. Is that not doing anything? I didn't click apply. There we go. Okay. So back down to 24. Okay. 24.5. Yeah. 24.35. There. That looks good. Okay, and now negative 68. It's a bit too high. Okay, so I think this right here, I think this is good. So now we can actually use this to go ahead, and we're going to go back to our camera. We're going to set our first nozzle over there, and now that we have these offsets dialed in, we can actually use that to set the position of the bottom camera, which is really important. So we're going to come here and make sure you capture the location the tool is centered on, not that the camera is centered on. So we're going to capture that. And now we can actually go ahead and just kind of round this to nice numbers. Now we have our nozzle offsets, we have our bottom camera, and we should be able to go back here and okay, so it wants offsets for the secondary fiducial. We can actually set those manually. Let's go to our reference head. So I like to clean up these values and round them just a bit. So same, this is the same. And now our secondary fiducial is a difference of 5 in the y. It's going to be 74. And it's going to be a difference of 10 in the x, so 236. We'll just apply that. Also, we want our diameters to be exactly 1, and apply it. This all looks good. Find issues and solutions. I did find, well, we'll just dismiss that because we don't actually need to do that. In single camera preview, no, so I don't want that. We don't want enable auto camera view. It's annoying. Milestone vision is complete. Now we have backlash compensation for X and Y. This is going to take about 10 minutes each, so hopefully I'm going to go ahead and fast forward this so you don't have to watch all of that. But first I'm going to go ahead and give you a large webcam view so you can at least see it in the fast forward view. Now, really quick, actually, let me pull that. What you're going to be watching for is up here in the top left, the last thing that it's going to do, the last text you're going to see is random moves, like a random move test or something like that. That's going to be the last stage, and then the text will disappear. And if it has completed successfully, you should not get an error. And then up here where it says open, it should say solve, and it should turn green. So that's what you're watching for when you do it yourself. You get a little pop-up that there's an error. You'll have to figure out what's going on. But hopefully it should complete successfully. So let's give you the camera back, and let's go ahead and go for it. Okay, just jumping in here really quick with an edit. I forgot to mention one thing, and that is before you run your backlash calibration, I highly suggest going into your axes, your X and Y axis, and change your soft limits so that they are 10 millimeters short of the actual end of the machine, both for top and bottom. We will make sure that we come back and set these back to their actual values later, but this will help by not running the calibration all the way to the edge of your machine, which sometimes was causing mine to crash. It stopped crashing after I figured out that the steps per millimeter were too high, and that was actually the reason why it was crashing, but this can help avoid a crash as well. Also, I seem to have set my fiducials incorrectly, so I'm going to just go ahead and fix those real quick. 216, I'm going to do 216.0 and 164.7. 0.75. Yeah. So when I ran my X backlash calibration, which after the edit is going to actually happen immediately after this, you'll see that it's running the calibration on the secondary fiducial instead of the primary. That was my mistake. But now I've got this set correctly. So now we're going to go back and do the Y. For you, we're going to do both. But that's why the X calibration is going to be off of the wrong fiducial. Don't worry, it worked out just fine anyway. Okay, so now that our backlash calibration has completed successfully, we are done with milestone calibration. And also milestone production because of some of the other stuff that we did kind of out of order from the way that they would have had us do it. I'm going to go ahead and rehome at this point. Okay. So, I forgot. We need to go back into our axes and reset our soft limits back to their actual limits. And now let's home. Okay. So now the last thing that we are going to do, so we can go through and we can accept these things. Let's see, the nozzle can be replaced with a contact probe. We do not have a contact probe, so we're just going to dismiss that. We can accept the async G-code driver. And find again. Now then we can enable this, and enable this. These are things that you might not want to accept these last ones, especially if you need to debug things. These end up removing stuff, but they're good for performance. I'm going to go ahead and remove them. This is another performance improvement that you might not want, depending on if you need to debug things. But again, I'm just going to go ahead and accept it. And now we are basically done. Now, there are a couple of things left, though, to do. Under parts, I'm going to go ahead and delete all of the parts that they included, except for the fiducial home. Don't delete your homing fiducial. And same thing in packages, delete everything except the homing fiducial, because you're going to recreate these parts and packages when you start to import board files, whether that's from Eagle or KiCad or whatever. Same thing here with the feeders. You're going to replace these with your actual feeders, which I'm not going to go into, but we want to delete these make-believe feeders here. Now I'm going to show you how to do nozzle vision pipeline calibration. Just some setup for that, as well as setting up the nozzles. So first of all, under our nozzles, we're going to go here. Under our tool changer, we're going to set a manual change location. If you don't have one of those, or if it's here down at 0, 0, it's not going to be able to reach it and it's going to complain. So we're going to just set this to 50/50. It won't let you manually change the nozzle if you don't have a manual nozzle change position. Now we're going to go to our nozzle tips, and kind of like with the actuators, it does things a little bit differently for the auto-generated ones versus the ones that get created when you manually create one here. So I'm going to delete the auto-generated one and come in here and create a new one from scratch. So our first is it's going to be NT045, and then I'm going to also create an NT08, because those are the ones that we have on here already. You'll go ahead and create all of your additional nozzles from there. I don't have any at the moment, but if you have any, I would go ahead and create them all right now. And you come up here to your nozzle and your nozzle tips and set them to compatible. Both of my nozzles are compatible with both of my nozzle tips, so we want to do that. Right now I have NT045 loaded onto the left, and there it's going to move it into place. This error is not actually an error. It is just a come on. Yeah. There we go. And then wait. There. Okay. So now, oops, that's what happened. So now we have nozzle NT45 loaded on the left nozzle and NT08 loaded onto the right nozzle. So if we want to do our vision calibration for those, here's how that's going to work. First of all, we're going to take our bottom camera and move the tool over the bottom camera. Okay, so now we can see here that should be centered. And it's a little bit off center, but it's pretty close. So now we go to our nozzle tip and our calibration. We're going to enable the calibration. We're going to come down and edit our pipeline. So this is what we see right now. So here's the mask circle. Now for me, I've tried detecting on this tiny circle in the middle, and for me that has not worked very well. I have better luck grabbing the outside of the nozzle tip here. So let's see, if we bring this down to a 120, that masks off here. Usually if I go with the really small nozzle, it finds a whole bunch of them all over the place, and I don't want to do that. This circle right here tends to be a good size that only gets found in the one place. You get your stuff dialed in right. So here we click on our threshold, and we can see this is no good. We need a much higher threshold, like, that's still pretty rough. Let's try even 90. 95 maybe? 100? Let's go to 95. Because then after we do that, then we blur, and this at least is a pretty decent circle. So now we come here to our detect circles, and we can actually see, we click here, which circles it's finding. So you can see that circle that it found is actually too small. We're trying to go bigger. So let's go with a maximum of 100, and this will actually tell us it found 3 circles. Now, 2 of them are at about 40, 45. I think that's that smaller circle diameter. So the 68 is probably the correct one. So if our expected circle is 68, then let's make our minimum 60 and our max, this should be like 75, and our minimum should be like 60. Now, if you're having trouble finding them, this param2, if you make this larger, it's more likely to find one. So if you get your diameter size right, oh, whoops, hold on one second, I messed that up, I selected the wrong one. The mask circle was 120, our threshold was 95, min distance was 50. Okay, so our max diameter was 75, min diameter was 60. So yeah, if it's not finding any circles, you can try and increase this. If it's finding multiple circles, you can decrease it. You can also decrease your min distance in order to say it has to be in the middle. But as you can see, we're only finding 1 circle right there. So that right there, and the dot shows where our center should be, which looks about right. So this pipeline looks good for this nozzle. So we'll go ahead and save this. And then we're going to do kind of the same thing we did before, where, okay, so now we're going to move the camera there, and then we're going to move, we're going to select nozzle 2, and then we're going to select the camera again, and we're going to move nozzle 2. So now nozzle 2 is sitting over top. So let's go ahead and apply this, and then we will do the same thing here. And edit, mask circle 120, threshold 80. Okay, so let's try a smaller threshold on this one. Yeah, that looks good. And then blur it. Good. So this diameter, because we're doing this outer one again, the diameter is basically the same size this time. So we're going to do the 75/60 again. And once again, we only get the 1. So it's 73, so we might actually increase that to 80. Interesting. Now it found one that's 66. But it's still only finding 1. That's good. Draw circles. Yep, it's finding it in the right place. Okay, so let's save that pipeline. Make sure to apply. So now that we've done that, oops, that's not what I wanted to do. Now we're on nozzle. Oh, we're actually on nozzle 2. Okay, there we go. Camera. We're gonna go back to nozzle 1. And now we're going to run the calibration. Machine not yet homed. Okay, home it. Fine. So actually, I didn't need to do this whole thing over here with flipping it around. This is the button that I wanted to use. If I want to move nozzle 1 over the camera, there it is. Turn that off, turn that on, calibrate. There we go. Okay. So, yeah, it found it. It was able to calibrate it. Now we'll go to nozzle 2. We'll run that calibration. And there it is. And I haven't found a need to run the calibrate camera position and rotation. That seems to be working fine. But if your bottom camera is rotated a little bit, then that would be, I believe, where you'd want to run that. So anyway, yeah. Again, make sure to save your configuration. That is crucial. But with that, that should be everything. And you should be able to start importing boards and parts and configuring your feeders, and then you should be able to run your machine. But that should be the full setup from start to finish. The one thing that I haven't been able to find in the settings yet, and if I do find it, I will go ahead and put it in the description. But what should happen when everything is set up with your nozzles and everything, when you hit the homing button, it should move the top camera to its homing position like this. So it should first move to the bottom left, hit all of the end switches, then it should move here. It should do your top visual homing, and then it's supposed to come down and do visual homing automatically on both of your nozzles if they're enabled. Mine isn't currently doing that, so there's got to be a switch somewhere. It might be down here. No, I don't know. There's a setting to do that. If anybody knows where that is, let me know, and I'll put it in the description. But that should be everything. And yeah, let me know if this was helpful. Let me know if you have any issues with this. And thanks for watching.